won't hurt. And what it will do is give you better context for identifying bones. Alright, so the human skeleton, you've all seen them before. We can break the human skeleton down into the axial skeleton. Axial is based on the word axis. It's basically the non-limb part of the skeleton. I will point out that because I couldn't really cover up the scapula is part of the appendicular skeleton, and I'll explain that in a minute. But the axial skeleton is basically everything in the midline. So the skull, the vertebrae, and the ribs and sternum. The appendicular skeleton, so the base word there is appendage. This refers to everything that's involved in our locomotion, everything that's associated with the upper limb and the pectoral girdle, everything that's associated with the lower limb and the pelvic girdle. So the upper limb consists of the clavicle, the scapula, the humerus, the radius and ulna. Don't freak out, we're going through these individually next. And the bones of the hand, which are the carpals, metacarpals, and phalanges. I think going into human anatomy for the first time, I didn't even know that there were two bones in the forearm, so that's kind of cool. You actually see skeletons. My undergrad anatomy professor would always put a Halloween toy on his practical and say, name 3 things that are wrong with this. And it was like kind of the sky's the limit, because once you start to know anatomy, it's amazing what people try to do with big skeletons, and it's pretty funny at times. Yeah, you'll see little skeletons all the time with like just one bone, the arm bone connected to the forearm bone or whatever. So yeah, there are 2 bones in the forearm, and the other term that you'll hear me using and probably hear me trip up on at some point is that, colloquially we refer to this as the arm. But in anatomy, the arm actually only refers to the upper arm, the humerus part. This is called the forearm. So the arm and the forearm. So this is the scapula. You may have referred to it your whole life as the shoulder blade. It's what you're feeling right here. I will tell you to touch yourself a lot in here. That's not kind of bad. But you've got an anatomical specimen for use. Don't forget that. Move, feel how things work together. As I'm talking about this stuff, shy of punching your neighbor's computer off the desk. Move around and see how some of this stuff works. So the scapula is the shoulder blade. The other thing I want to go ahead and point out to you guys is that whenever possible, I'll have a little guide skeleton down here for you guys. So if you're looking at it thinking, I don't know if we're looking at it from posterior or anterior view. This guy's down here to remind you. Sometimes we're looking at it sort of in an oblique view or something like that, where I can't do that as easily. So I'll try to always have a label on there telling you how to be oriented on it. So just keep in mind that that'll be there for you guys. Don't get confused. And I use type weight purple, not really type weight. Good colors. I seem to like it a lot around here. Alright, so the scapula, the one thing I will point out is that I think because the scapula is located so posteriorly, we kind of think about it from an outside-inside perspective. So it's easy to get confused about what you're seeing from the outside versus what's anterior and posterior. And the thing that I'll point out is that the flat portion of it is the anterior view. But because it's up against the rib cage, we don't think about it in anterior view a lot. So don't get disoriented by that. What you're feeling is actually what's called the scapular spine. And that's kind of that ridge on your back, the shoulder blade, I guess. The clavicle, so that's the collarbone. People break it all the time. And again, that's another one to identify. And we'll talk about it when we get to the upper limb. If you actually think about bony articulations, so an articulation is just where 2 bones meet and have a joint. The clavicle is actually the only bony articulation attaching the upper limb to the appendicular, or to the axial skeleton. This is actually why we break it so often, and I'll probably forget myself and repeat this, but the attachment is so tight at the sternum that you're more likely to break it than you are to dislocate it there. Okay, cool. The humerus is the only bone in the arm proper. So that's actually what we think of as kind of the conventional shoulder joint, and then it also forms the proximal component of the elbow joint. Humerus comes from the Latin word humerus. I don't actually know how to speak Latin. I just know a lot of pieces of it from learning anatomy, and that just means so it's not all that important. I like to, wherever possible, throw out like why things have the weird Latin names they do. Sometimes they're really descriptive, and sometimes it's like, oh come on, like nobody knows what that thing is anymore. Like this was something that you weirdly saw like 200 years ago. There's, you know, a valve in the heart that's named for a bishop's mitre, which is the silly hat that they wear. That's not actually very good descriptive language in my mind. I would want it to be named after something I'm a little more familiar with, or just named whatever it is. But on the whole, anatomists are pretty good about telling you what a thing is in the name. And wherever that's helpful, I'll try to point that out to you guys, because that can be really good for remembering things. For example, the radius and ulna. Radius and ulna are the two bones that form the forearm, and they each have sort of a distinct function. So if you think about the two major things that the forearm can do, it can flex and extend at the elbow, kind of the conventional elbow movement, right? And it can also, like we talked about before, pronate and supinate. And each of those bones is sort of individually involved in one of those two roles. And that's reflected in its shape. And again, this is stuff that we'll get into in a lot more detail when we do get to the upper limb. But the two bones are the radius and ulna. So go ahead and feel them yourself. We've got the ulna, which ulna refers to elbow, and that actually is the bone that you're feeling when you touch your elbow. It's got this nice U shape. I always reminded myself that the ulna was the one with the U shape in it. And that's what's holding on to form the elbow joint. And it's a nice little pivot that actually does facilitate that flexion and extension at the forearm. So the ulna is responsible for flexion and extension. Laterally in the anatomical position, we have the radius. Radius should remind you of the word radiate. And it's the one that actually is responsible for that pronation and supination movement that takes place there. And so this is something that you might not have thought of much before. But if you actually feel where your radius and ulna are in an anatomical position, they're parallel to each other. But when you go to supinate your arm, virtually nothing happens to your ulna. It's pretty much all on your radius, and your radius actually goes and crosses over your ulna. Feel that? The two completely different movements that happen here. Carpals, metacarpals, and phalanges. I'm not asking you to learn individual names for any of these yet. I just want you to be familiar with what they are and where they are. So the carpals are these little lock-shaped bones that form the wrist. And you see a whole lot of bones with little joints in them. It's going to give you like sort of a big range of mobility. These are just the little wrist bones there. Think about it, when you call opposition of the fingers, and those are helping to allow you to kind of smoosh the wrist in on itself like that. Okay. The long bones here are metacarpals. And I think we sort of forget when we look at a human skeleton or an X-ray or something like that, that those are, nice long bones that look like they're part of the digits, but they're actually completely contained in your hand. So those long bones here, you just have one of each, one for each digit. Kind of the weirdest experience that I've had with metacarpals was one time when I was working as a vet tech. I maybe jammed my finger really hard on a dog and head or something. They're always bouncing around. I don't remember. My finger hurt really badly, so they x-rayed it. And I had my wedding ring on, and it just looked like it was like all the way at the tip of my finger. It was just way out there, and it's because I wasn't used to thinking about metacarpals, putting the digits so far out there. So that's kind of a fun thing to see. But yeah, so you got metacarpals contained in your palm. And phalanges. So phalanges is plural. An individual bone is called a phalanx. So you have proximal, middle, and distal phalanges on these 4 digits, and then just proximal and distal phalanges on your thumb. Use the anatomical terminology already. How does it feel? Okay. Any questions about that so far? That's the level that I want you to know it at. But realize that you may see some of these bones, pulled out of articulation. I'm not going to give you the context of, this is a bone of the upper limb as opposed to the lower limb. So be familiar enough with what they look like that you think you could ID them. Okay, so the lower limb again consists of the pelvis. This is the femur, the patella, this is the kneecap. Toddlers don't have patellas yet. It takes a few years to develop a patella. They are bones that develop in cartilage, so you don't start out with a bone there. This is the tibia and the fibula, and of course the foot and ankle. Just like with the upper limb, it's a little bit counterintuitive that you have the arm and the forearm. With the lower limb, we have the thigh and the leg. So the leg doesn't actually refer to the entire limb. The leg is actually the lower part of the lower limb. So again, that's the thigh, which consists of the femur, and the leg, which consists of the tibia and fibula. Okay, so the pelvis. The pelvis developmentally is composed of 3 bones, which become fused to each other during development. I will show you where they are, but generally in adults you can't really pick out the sutures anymore because they fuse so completely. Things are more structural stability. If there were patent sutures, that would be a place where it could fail. That's good because it's carrying a lot of the body weight and transferring it as you walk, run, whatever. Okay, so this is the pubic symphysis where the two halves meet anteriorly, and then they both also attach to the sacrum, and that's what's anchoring the pelvis to the axial skeleton. So the pelvis consists of the ilium, the ischium, and the pubis. The pubis, as the name sort of implies, is in the pubic region, so anteriorly, and it's got 2 rami. So a ramus is a branch, so as you can see, it's kind of got a V shape to it. The ischium is the one that you feel kind of like the butt bone, if you will. That's great anatomy right there. But if you are sort of a bonier or thinner person, sometimes you can feel what's called ischial tuberosities kind of sticking out there. So it's not, you can also kind of feel your sacrum and your coccyx back there, but lateral to that, that's the bone that you'll feel. And your ilium is kind of the broad, flat bone up top that provides a good source of muscle attachment and sort of forms the basis for your abdominal organs up there. You can usually feel what's called the anterior superior iliac spine. Anteriorly, that's the part that juts out right there. Okay. From posterior view, the same 3 bones, the ilium, the ischium, and the pubis. And they all have sutures joining them in what's called the acetabulum. Acetabulum means like basically acid cup or vinegar cup, and refers to the idea of, I guess, being able to drink wine out of the little cup-like portion that articulates with the femur. So they actually do developmentally have a suture within that cup-like portion. So I encourage you definitely to take some time to really get familiar with the pelvis. And obviously we'll get into it more both with respect to doing the pelvis and also learning about the lower limb, which is pertinent to both of those things. But it's a pretty complex dimensional structure when you think about it, and it's taken me a long time to kind of get my head around it. So do take some time to really get familiar with it. Okay, the femur is the thigh bone. My favorite thing about the femur, this is a little barbaric, but something about picking up a femur, they're just like so well weighted that you just want to hit something with it. Like, I think that somebody probably snapped this ball-like femoral head off of one, and baseball was born. Like, it is the most caveman-like tendency, but like, something about holding a femur just makes you go. Don't do that, because they'll bring the femurs and they'll be really mad at you. But they're just delightfully weighted, and it makes sense, because we actually are depending on them pretty well. It's like the difference between having a coffee cup where the handle's in the right spot and one that's not, and it always tilts on you. They're just really nice bones that form a very important function for humans. But I love the femur for that reason. It's just fun to hold. Tibia and fibula are the bones of the leg proper. It actually kind of looks like this if you stop and think about it. But the tibia really is the only one of the two that's very much weight-bearing. The fibula is sort of a site for muscle attachment there, but it's not really bearing much of the body weight. I looked at the names of these because I was hoping that there would be something sort of informative about the names of them, but they're actually terribly disappointing. The fibula is based on a Latin word for brooch or clasp, because apparently it looks like it forms kind of in like clasp with the tibia. Sometimes they're named really well and sometimes they're just not. But tibia and fibula, sort of a tongue twister there. I think every anatomy student I've ever taught has been like, I said fibula or something like that. Yeah, it's just hard to keep them straight. Tibia and fibula. I guess I get cynical. You know, my anatomy instructor, who was a mentor and someone I knew pretty well, always said, you know, you teach it for 13 years, and finally you're like, I've been teaching this for 13 years. Why haven't you learned it yet? Because you're learning it for the first time. But it's something that you have to remember people are just kind of encountering for the first time. So same sort of stuff comes up every year. I don't mean to be too cynical about it. So in the lower limb, we have tarsals, metatarsals, and phalanges, sort of like the carpals, metacarpals, and phalanges that we have in the hand. The tarsals, again, are the block-like structures that form the ankle. The metatarsals are the long bones that are contained in the plantar portion of your foot. So the plantar portion is the part that's like the palm of the hand and the foot. And again, the phalanges. And just like with the upper limb, the great toe only has 2 phalanges, whereas the other 3 have 3 each. That makes sense, you know, those are the joints of your fingers. You can see that very clearly. Okay, so this is as far as I got with, oh no, I lied, I haven't done the axial skeleton. So the next part is to run through the axial skeleton with you guys. And what I hope to do, we've got about 15 more minutes. I want to introduce the axial skeleton, and that's where I stopped with the other group. But I want to go ahead and introduce you guys to a typical vertebra and some of the structures that we'll look at on there. So I know that I said that I just want you to get as far as IDing the bones, but we are going to go into actually IDing structures on vertebrae. So I'll give you guys a schematic of a vertebra and run through that. And if we can get through that today, you guys will be one step closer to being caught up with the other group. Okay. So the axial skeleton, again, consists of the skull, the spine, the ribcage, and sternum. Skull and mandible, pretty straightforward. You guys all know what a skull is, and the mandible is the jaw. Mandible is one of my favorite bones because it's involved in chewing, and that's what I study. Kind of an interesting thing that some people may or may not know is that humans and several other species, including Jews actually, fuse the mandible into a single bone during development. But plenty of mammals also don't. Dogs and cats, for example, retain a patent mandibular symphysis. So they actually have 2 dentary bones that form the mandible. We have just completely fused our 2 dentary bones. So we just have one bone for the mandible. Sternum. The sternum consists of 3 parts. This is called the manubrium. It's where the clavicles attach. This is called the body of the sternum. This is where the ribs attach. And this little process down here is called the xiphoid, which is just a really fun word. Xiphoid process. Kind of cool thing about the xiphoid process is that you guys probably don't have them yet. They start out cartilaginous and become ossified into bone later in life. Clinicians often find that people will come to them in their 40s and say, I think I have cancer. I have this bump here that I didn't used to have. And it's actually just because they have ossified their xiphoid and just noticed it for the first time. If you look at a great number of human skeletons, the xiphoid actually takes on different shapes. So sometimes it's sort of like wonky and asymmetrical. And I've always secretly hoped that I have this symmetrical xiphoid just because I know it could not be. And I don't know, I'm a nerd, I don't know. So yeah, the sternum consists of the manubrium, the body, and the xiphoid. Breastbone, I think people call it. I'm trying to think if there's another colloquialism for this sternum. I think people actually use the word sternum for that sometimes. You kind of forget because you start calling things by their proper names. You can't remember what you call them growing up and stuff like that. Ribs. We have 12 pairs of ribs. There is a myth out there, I think it's based on sort of the Adam and Eve story, that males have fewer ribs than females, and that's actually not true. I grew up having been taught that just in elementary school, I think, and I'm just always assuming that was true. There are people with supernumerary ribs and people with fewer numbers of ribs. We, like evolved from lizards that have ribs actually all the way down the spine. So our spine actually has remnants of ribs that fuses onto them, but that's neither here nor there. We won't learn it in that level of detail. But we have 12 pairs of ribs conventionally. Almost everybody does. Some people just have it. You can actually have an extra cervical rib that can put pressure on some of your nerves that pop out there and cause pain. And people don't know they have them until they have problems that develop from them. My advisor was convinced she had a cervical rib, but it turned out she actually just had a badly herniated disc and had to get surgery done. But I think she was hoping for like sort of the more interesting, goofy thing. Anyway, so we have 12 pairs of ribs, and they're divided and color coded accordingly into like proper ribs, true ribs. And the distinction is, actually they're all technically true ribs, but the distinction is that the ribs end anteriorly in what's called a costal cartilage. So cartilage, unlike bone, is a little bit more flexible, and because we're moving our ribs in and out all day long every time we breathe and as we move around, it's kind of nice to have a cartilage attaching it to the sternum. So true ribs in cartilages that attach them directly to the sternum. The false ribs below them actually have cartilages that attach to the cartilages above. So they don't attach directly to the sternum, and that's what makes them false ribs. And then we actually have 2 pairs of floating ribs that don't have any costal cartilage at all. You can sometimes kind of feel those down there until the ends of them. And, they're just involved in protecting those organs. That's some really important stuff in there. The spine. So the spinal column can be broken into a few different sections. There's 7 cervical vertebrae. So vertebrae is a unit of the spine, and the singular of that is vertebra. 7 cervical vertebrae. Cervix means neck, so 7 cervical vertebrae. There are different numbers in different species sometimes, so other mammals may have fewer or more depending on how they're allocated. 12 thoracic vertebrae, and the distinction there is that those are the vertebrae that are attached to ribs. 12 thoracic vertebrae. We have a lot less mobility in our thorax because we do have a rib cage there. So cervical vertebrae allow for a whole lot of neck movement, and then below the thorax we have a lot more mobility also in our lumbar region. We have 5 lumbar vertebrae. And then the sacrum. The sacrum you saw before because that's the bone that the pelvis attaches to. And the sacrum it develops from 5 vertebrae that fuse together. So it's formed from 5 vertebrae. And you can actually kind of see where they were when you look at a sacrum. And then we also have the coccyx. And the coccyx is a very reduced version of the tail. So we have usually about 3 to 5 very reduced vertebrae that form the coccyx. Other mammalian species typically have caudal vertebrae instead of a coccyx, but that doesn't mean that they're utterly not functional in humans. In fact, the coccyx plays some really important roles. First of all, we have filaments anchoring our spinal cord to them, so it actually helps it to stay in place, and it also tucks up under and allows for the attachment of the pelvic floor. So we've got a sheet of muscle basically that attaches to the coccyx. And that's really important for us because we're bipedal, so we've got body weight and pressure pushing down on that pelvic floor all the time. And if those muscles give out, it can actually prolapse our organs, which is a mess that nobody wants. So the coccyx actually does still play an important role for attachment in humans. So that's as far as I got with the other group, and we've still got about 7 minutes, so I'm going to go ahead and walk you through just IDing some of the parts of a typical vertebra. So this is a schematic version of that. And again, don't panic because in lab next week we will label something exactly like this. So just pay attention and get familiar. So the vertebrae have, in spite of where they are, they have some parts in common. And that's what I want you guys to see today. Now, regionally they will have some different distinctions, and we'll also point those out, but we probably won't get to that until Monday. So vertebrae have vertebral bodies, and those are the parts that are stacked on top of each other. They have a vertebral disc in between them. And they have a vertebral arch, and that's this whole structure back here It has all these processes coming off of it. We can further break the arch down into a pedicle, which is closest to the body, and a lamina, which is out closer to what's called the spinous process. And that's the spinous process. Those are the parts that you feel. So those are the parts that are sticking out dorsally, right? I'll go back for a minute so you guys can get all that. The vertebral body here, the vertebral arch out here, the pedicle, and the lamina. And then we have the spinous process. Okay. And then out to either side we have what are called transverse processes. So that makes sense, right? We would learn the term transverse. It means kind of going out to the side like that. There are two transverse processes. And then superior and inferior articular processes. Okay. So articular, again, refers to the fact that they articulate, which means that they have a joint with another bone. And what you'll see if you look at a spine is that the superior and inferior articular processes just end up overlapping with the ones above and below. So this hole right here is called the vertebral foramen. And as you can imagine, if you strung all these things together like a necklace, like you have in a typical spine, that vertebral foramen is just continuous all the way through. And that's what your actual spinal cord is running through. Okay. And then we also have an intervertebral foramen. So it doesn't make a ton of sense when we're looking at a single vertebra, but when we put them together, you actually have those notches of the adjoining vertebrae that form the intervertebral foramen. So it's actually formed by two on top of each other. Okay. So, as you can imagine, you've got the stack of vertebral bodies with the intervertebral discs in between, and then the vertebral arch coming out this way. You can see the spinous process is back here, and the transverse process is sticking out to the side, right? And then we've got the articular processes overlapping between them. And the vertebral foramen is running all the way through here. It's protected by that vertebral arch. So your spinal cord would be running right through there. And then the intervertebral foramen, formed by the adjoining vertebrae, where each of these purple stars are, is where you'd actually have spinal nerves coming out. You have a spinal nerve in this location that's going out to provide innervation to the rest of the body. And that's what we're going to get to next. Yeah, from there we go into individual vertebral features, and I think that's a little bit different for today. So if anybody's got any questions about anything,